Welcome everyone. I'm Priyanka and I'm here to introduce you to the concept of synthetic data generation. Before we start, let me introduce you to DataCreator AI. DataCreator AI is a synthetic data generation platform that allows you to generate custom synthetic data sets in minutes using only natural language instructions. The main goal of this platform is to combine synthetic data with the uniqueness and diversity of human experience to create high quality training data for the future. In this video, we will briefly introduce synthetic data and its advantages. Then we will discuss some real-world applications followed by the challenges that come with using synthetic data. Then the discussion will take a slightly technical turn where we will discuss important research papers that will give you more perspective on this area. So let us start with the question of what is synthetic data? Synthetic data is defined as data generated by AI models that are further used to train, evaluate, and fine tune other models. It looks like real data, but it is entirely machine generated. Synthetic data generation has been popularized recently with the rise of LLMs, but it has always been a part of the ML process. Almost all different modes of data can be generated artificially. If we see here for text, you can generate it with either recurrent neural networks or large language models. For images, initially generative adversarial networks were used, and now you could also use stable diffusion techniques. For numeric data, statistical simulations and random sampling from statistical distributions can be used. Next, let us understand why synthetic data is needed. Don't we have enough data already? The answer to that question is no. We do have many public repositories like Kaggle, UCI Machine Learning Repository, and Hugging Face. They're great for general purpose datasets, but when you have a specific niche use case, you may not be able to find such a dataset very easily. Even if you do, it might not be in the format you expect or be enough in terms of size because AI models need a lot of data to perform well. This is a real difficulty because 35% of total data science work on average is spent on data collection and curation. This time can be reduced significantly if you have a tool that can generate a data set in a few minutes just using natural language instructions. One other reason we need synthetic data is that real data can be expensive to collect. Take the example of surveys for medical research. We first have to find people who come from different backgrounds, track their progression of their symptoms and other attributes like life expectancy, age, and this can quickly become expensive to scale. Also, in such cases, many patients may hesitate to give personal medical information and it will be illegal to track it without consent. So, one other option that you might think you have is web scraping. But web scraping can't be the solution always for many reasons. After the rise of ChatGPT, there were many lawsuits claiming that OpenAI illegally scraped a lot of websites and used copyrighted content to train the GPT models. You may also have recently heard about how Reddit sued Claude, alleging that they have used Reddit data to train their models without permission. We also have many other similar cases like the New York Times suing for scraping their content without permission. Since then, many websites they've started to paywall their content and they're not allowing scraping. Let us say a website has allowed scraping and if you have obtained this data, there is no guarantee that it will be of good quality. And speaking of quality, we all remember how Google was trolled for the weird responses of AI search answers like sticking glue to make pizza. There was a rumor that this data was obtained from Reddit data, and the training data included some sarcastic responses. This could be fine, but not suitable for search results. This highlights the importance of quality over quantity again. Moreover, multimodal and numeric data is difficult to scrape. The internet initially was predominantly text based until very recently, and scraping for specific numeric or multimodal data is relatively more difficult. The different modalities are also often not inherently compatible, making it difficult to scrape and aggregate them effectively. So the point here is less is more. Quality over quantity is the motto going forward. High quality smaller data sets are better than low quality larger data sets. So now that we've seen why we need synthetic data, let's see some real world success stories. The five models by Microsoft have successfully managed to achieve high quality based on a mix of synthetic data generated by the GPT model and also the real data obtained from textbooks. This training with high quality data has helped five models achieve equal performance to 7 billion and 13 billion models with only 2 to 3 billion parameter models. This process was first mentioned in the paper Textbooks Are All You Need. In the e-commerce industry, Amazon One is a fast and convenient service that allows customers to make payments and enter the venue using only their palms. So they needed a large data set of palm images to train the system, including variations in lighting, hand poses, and conditions like the presence of a bandage. The team even trained the system to detect highly detailed silicone hand replicas using AI generated synthetic data. And this has led to a lot of success with almost 99% accuracy. In the field of finance, financial institutions such as MasterCard and American Express use synthetic numeric data to train credit card fraud detection algorithms. To maintain privacy and comply with data regulations, they generate synthetic transaction data that mimics patterns of genuine and fraudulent activity. This allows the system to train on large scale anonymized datasets without risking exposure to personal information. So, these are some of the success stories of synthetic data in the real world. But, like in life, even here, there are no free lunches. Now, let us discuss a bit about the challenges of applying synthetic data. The first one is the lack of realism and diversity. One of the most critical challenges is the lack of realism in synthetic data. Although it can replicate patterns and statistical properties of real world data, it often feels it often fails to capture the intricate nuances and complexities inherent in actual data sets. For example, when you're generating customer purchase data for October in India, during the festive season, there might be spikes in purchases in real data, which the synthetic data will not be able to replicate correctly. The next is dependency on original data quality. So, in many cases, there is some real data available, but it is not enough for training AI models. In such cases, we go for data enhancement by providing the real data as few short examples. We have this feature of data enhancements on DataCreator AI as well. You can try it out after watching this video. So, in such cases, if there is a bias or imbalance in the data, the generated data set might mimic that too, and the bias is still there even after combining the synthetic data and the real data. The next problem is the loss of outliers and rare events. As some of you who regularly work with LLMs might already know, in most cases, LLMs work on the highest probability at each timestamp. So we are ignoring less probable tokens at every step. This holds for most machine learning models as well. In this process, the less likely events and the tails of the distribution are ignored. When we use these models for data generation, they tend to repeat the most probable events and ignore outliers and exceptions. Apart from this, there is also the constraint of limited domain knowledge. Domain knowledge is the key challenge to synthetic data. I will give you an example from my recent work. So, I was working to generate data about German universities. German grading systems, they work in reverse, which is the lower the grade, the better it is. Because I know this, I was able to prompt the system to generate this grading system correctly. The models inherently did not know this and they've assumed that a higher number is the best grade. Now, this is a very simple example, but domain knowledge is extremely important to generate synthetic data that for niche use cases. Research happening in this space. These papers that we are going to discuss are some of the three papers I found very interesting, and there are also some techniques that will be added to our platform in the coming months to assist you in generating better data sets. The first one is scaling with 1 billion personas. So, in this paper, they have consolidated all the web data and created a billion kinds of people, which they call personas. They use two kinds of techniques to achieve this. The first one is text to persona, and the next is persona to persona. This could be very useful to generate data that includes 1 billion diverse perspectives. You need not include all of them, but only the ones relevant to your specific use case. The next paper is Synthesizer. This is another important paper that has been released in July 2024. This paper proposes combining retrieval augmented generation with synthetic data generation. They've generated text classification datasets by including some context. This picture shows the process on a very high level, wherein they give the labels and they generate enough data points for each label. So the next paper we have is about model collapse. So in this paper, the authors have observed that training only on synthetic data, which is AI generated, leads to model collapse at some point of the time, but a mix of synthetic data and real data slowed it down. So like we discussed while talking about limitations, the data distribution changes on repeated training with data from other models. So in order to avoid in order to avoid problems like model collapse, it is important that synthetic data is combined with real data and is also reviewed by humans so that it reflects our actual lived experience. Discussed the positive and negative sides of synthetic data. But let's see synthetic data in numbers. According to the Gartner website, as of 2023, 5% of companies are using Gen AI to generate synthetic data, which is projected to increase to 75% by 2026. As we discussed in the previous slides, less is more. More businesses are moving towards AI models that are tailored to industry specific functions. Until now, we have seen more general purpose AI models. While they are moving towards AGI, which is artificial general intelligence, more traditional businesses are looking for customization and privacy. This trend is projected to increase up to 50%. Apart from this, the global synthetic data market is set to grow by 38.9% by 2030. So, most of the AI derived consumer data, when triangulated, is coming in around 90% similar or as accurate as data generated from primary human sources. So, so what we understand from all this, what do we understand from all these numbers? That synthetic data can be a huge benefit when it comes to training models for niche domains. So, so until now we have discussed a lot about synthetic data. Now let us make some predictions. As we have seen in the data section already, there will be far wider industry-wide adoption of synthetic data in the next few years. The most important prediction from my perspective would be that we, humans, are the future of synthetic data. To tackle the challenges we have discussed, especially like a lack of realism and lack of domain knowledge, humans must be in the loop. This is also what the research says as we are going to this is also what the research says as we have already seen in the model collapse slide. Ultimately, AI products are for people. Until and unless there is a robot uprising, I don't think we can build good AI applications without human input. The other trend I see is that of explainability. So, in the past few years, explainable AI has become more prominent. So, when a model gives a specific answer, we want to understand why the model does so. So, for the model to have explainable AI, we must look at the data it was trained on. In this case, We would like to explain why and how a certain type of synthetic data was generated and whether it was reviewed or connected. So I think explainable synthetic data will become more important in the coming years with the rise of explainable AI. So in this video, we have had a very brief and high level introduction of synthetic data. And in the coming videos, we will understand the applications of synthetic data in various fields. And also we will see specific use cases along with their respective code, understand how synthetic data is applied in the real world to enhance AI models. So thank you for listening. Subscribe to this channel for more such information on synthetic data.